Hi everyone, I'm Dr. Surjit Singh. Today we will talk about the lead code problem, removal of the nth last node from a linked list. Welcome to my video. Let us begin. Given a linked list, we are to remove the nth node from the end. In the first solution, we will process it in two passes. In first pass, we will find the length of the list. In the second pass, we will find the node to be deleted and its parent node. We are given the head of the linked list and we are given n is equal to 2. N is equal to 2 means that we are to delete the second last node of the list. We define a dummy node and initialize its val to 0 and next to none. Next we assign head to its next to attach this dummy node in front of the main list. In the first pass, our aim is to find the length of the given list, so we set length equal to 0. Next, we define a variable node and point it to the head of the given list. Now we run a loop over all the nodes of the given list. We run the loop while node is not none. Inside the loop, we increase length by 1 and move the node pointer to the next node in the list. In the next iteration, length becomes 2 and we point node to next node with val equal to 3. Then length becomes 3 and we point node to next node with val equal to 4. Next, length becomes 4 and node points to the next node with val equal to 5. Finally, length becomes 5 and node points to next node which is none and the loop terminates. We subtract n equal to 2 from length equal to 5. The remaining value is 3. This means that we need to skip 3 nodes from head and then delete the next node. Whenever we want to delete a node, first we need to identify its parent node. The parent node is 3 steps from the dummy node. So we define a pointer called parent and give it the initial value equal to dummy. The reduced value of length is 3, so we run the loop 3 times and in each iteration we decrease length by 1. Now length becomes 2 and simultaneously parent is moved to the next node. In the second iteration, length becomes 1 and parent shifts further in the list. In the third iteration, length becomes 0 and parent moves one step more. Now length has become 0 and the loop terminates. Now we have found the parent of the node to be deleted. In order to delete the purple node, we need to point next part of parent, which currently points to 4, to node with val equal to 5. Next component of parent points to the node to be deleted. So we need to point the next component of parent to the next of the next component of the parent. Note that address of the node with value equal to 4 is no longer saved anywhere. So it is a dangling node. It will be given back to the operating system at the next cycle of garbage collection. This means that the deletion process is over. So we return the next part of the dummy node. It will be wrong to return head as a result because if the given value of n is 5, head would be the node to be deleted. At the end of the function, all the local variables become undefined. Returned pointer becomes the head of the final linked list. This program explains the use of dummy head for any linked list. Now let us discuss the time complexity. There are two while loops running one after the other. If L is the length of the list, first loop runs L times while the second loop runs for L minus n times. So time complexity is of the order of L. No extra space is needed for the linked list. So except for a few local variables, no extra memory is needed. In this method, we use two pointers that are n nodes apart and they move together along the list. When one pointer reaches the end of the list, the other contains the parent of the node to be deleted. Once again, we attach a dummy node to the front of the main list by storing head in its next part. We define two pointers, node and parent, with initial value dummy in both of them. The gap between the node to be deleted and the end of the list has to be equal to n. But parent node is one position before the delete node. So the gap between the two pointers should be equal to n plus 1. We run the loop n plus 1 times and move the node to the next position each time. At the end of the loop, parent is at val equal to 0 and node is at val equal to 3. Next, we start moving node and parent together in a loop. In the first iteration, they reach 1 and 4. In the second iteration, they reach 2 and 5. In the last iteration, they reach 3 and none. Now that node is none, the loop terminates. It means that the parent of the delete node is the node with val equal to 3. We have to remove the node after parent. So we point next item of parent to the node after one node is skipped and return next part of dummy as the head of the new list. Time complexity is of the order of the length of the list. No extra memory is used, so the space complexity is constant. Thank you for watching the video. Please stay tuned for my new videos and subscribe to my channel.